Okay, before moving to the other cases, to clarify something, to explain something, here you have these solution folders, and very often you're going to see solution folders. Let me show you know how to use those. So in this case, you go find mesh. So to avoid rerunning the cases, and if you want to do only the post-processing and so on, and let me go in particular to S3. Just take this, Control C, Control V, put it there, and you're ready to go. So you're copying the mesh. Okay. By the way, solutions. Give me a minute. Then you have S3. You have the mesh. Okay. So sorry. So you have the solution, and the folder call it S3 for mesh. You have the mesh, and at this point you go here, paraview. Built-in, as I say, I recommend you to use the built-in option. Is faster than the paraview only. And let's open paraview state here. Let me see what was the problem. So check mesh. Boundary, I have everything. Okay, so see that we have the mesh. This mesh is almost 7 million cells. It's okay. So let me, I can recall what was the. Okay, so let me go here. Low state paraview. Okay, so we have reconstruct case. And be careful that paraview already is 6 million. It starts to become a little bit slow depending on video cards and so on. So sometimes I recommend you to instead of using this native format of paraview BTK that tends to be slow with OpenFOAM, convert it to Insight format. So you have the font to Insight, tends to be faster. No, it's much faster. Font to Insight. Well, be careful then, there is some filters that you need to apply to get the data, but it's not a big issue. So probably we'll do a video on that. There you go. So see that now you have this no store state behavior, and I want to show you that this is a fine mesh. Look at that. Very nice mesh. Okay, even though this behavior that you see here was the collapsing of the original mesh, the castellated pure snappy, but then when you add the boundary layer, you are offsetting that behavior, and the boundary layer will add now the normal layers, and that will help a lot. Okay, so let me go here. Let me put the boundary layer there. And actually, as you can see that this is also well, okay, I didn't put, but in this case, I think there is one with 15 actually there. You can get to 15, 18 layers with no problem. And see that you have your nice boundary layer. Look at the propylene region, all the refinements are applied there. So as you open the dictionary, you will get all the tricks that I use. Look at that in this region can be problematic. Also, I apply some refinement. Now by inspecting here, this one, okay, I didn't get this one, but see that these transitions are not recommended. So maybe it will be better to increase this distance here or have a uniform refinement in the spinner. But this is no good here, and that's it. Okay, so this is how you can get the cases. You have the README. Okay, let me go font clean tutorials. You have the README, and in each case that you see solution is an ID. Okay, so let me see the README with Open3. Let me see. We have S5 with 15 layers actually, so let's take a look at this one. So, okay, I put everything here. So let me take here. You have everything. You have the post-processing, you have the log files. If you want to see the convergence, if you want to monitor the forces, you have it there. So let me put here, and polymesh, remember that should be here. Let's go. And let's take a look at the mesh with 15 layers. Okay, use the wrong command. Solutions, find mesh, okay. Put this one here, and paraview built-in. Reconstruct, yes. Okay, as you see, it took a while, and actually, I don't recall, but you can get an idea that now this one is much larger. So let me open, actually, don't have to check mesh, but in any case, I can get it from, so you go more constant polymesh and neighbor, and in the header, okay, neighbor, not a text file, okay, header, 30, and using in the header here, you have number of cells, 11 million. So see that usually when you start to have 15, 20 cells, you are going to double your mesh cell count. So previous one was 7, look at that, now we're at 15, 12 million cells now. So since they start to become expensive. So let's take a look at the surface values. Body. Post-processing is heavy. In this case, the inside format is very handy. There you go. Very smooth, no sign of that stair-step behavior. And the surface mesh also very nice there. And now let me add this one, and also normal to Y. Okay, so there you go, show plane, and this one, and now let me go zoom in, and this is it. So look at that. Many people complain it's difficult to have that, to concentrate, and actually I think in this case I managed to add 15 layers. No, 25 layers. So here there are some issues. Recall that the geometry, there are some issues there, the curvature. Then recall also that there is not enough curvature here. There is that sharp angle. Now we're not looking in the best position of the geometry now. So there are many issues on the boundary layer related to the actual underlying geometry. But look at for the rest, everything nicely captured here, nicely captured. And I wanted to look somewhere here. So see here that, so you look at the surface, likely this point will be that strange behavior that you see in the behavior. So you shift it there at your boundary layer, now everything is normal. So yeah, that's what I wanted to show you. This is the 15 million. Let me go and let's take S1. S1 is the one without the boundary layer. So let me put it, cancel. Fun, clean tutorials, put it there, solutions, S1 mesh, I need this folder, put it in constant, and let's paraview built-in. And let's take a look now at the surface mesh. Here we should have that stair-step behavior, boundary layer. This state 1 Here we go, reconstruct case. And there you go. So the behavior was mentioned. And, well, you get the idea that when you integrate in the surface, this is going to add some errors in that integral. Yeah. So recall also now when we look at the collapsing boundary layer, now the previous one, that look at that here, it is not curvature, no, there is not a lot curvature, so you have those issues. Then there was an issue there. Well, there you go. So that's all. So now let's move now to the next series of videos. So see you next time. Bye.